the global mining sector is fully engaged in an energy transformation that's centered on saving costs, securing power, and reducing carbon emissions. All of you are at the forefront of this exciting transformation, whether you're a mine looking at new solutions or an energy expert providing that expertise to mines. I'm Adrienne Baker with Energy and Mines, and we've been looking at or working to connect the mining and renewable sectors for the last 6 years. This is actually our 14th conference on this topic after doing events in Chile, the UK, Australia, and South Africa. We're very passionate about renewables for mines and very excited to see the level of activity in the market that we're seeing today, with more mines than ever investing in and assessing renewable energy solutions. Over the next couple of days, we're going to hear about new projects, new assessments, and new milestones for renewable energy for the mining sector, and other important solutions that are playing a strong role in this transformation. We'll also hear, and this is maybe more important, about the remaining barriers to having all mines on affordable, reliable, and low-carbon power. I'd like to thank our thought leader sponsors, Caterpillar, Sterling & Wilson, and the Canadian Trade Commissioner Service, and thanks as well to all of our sponsors and supporters. It is now my pleasure to introduce Kim Tretter. Kim is the CEO of De Beers Canada, and we're delighted to have him opening the Congress this morning with this very important topic of 100% renewable energy in mining.
Good morning, everyone. As Adrienne said, this is a fantastic opportunity to share some notes about how we're going to change the future. Just as a bit of an icebreaker, I wouldn't mind a bit of show of hands. How many in the room are actually responsible for designing new mines? Kind of thought that was going to be the case. About 10 people in the room. You're going to hear two messages from me in the next few slides. The one is because we are a diamond company, we are probably the most consumer-facing mining company on the planet. And because of that, we have to have our finger on the pulse of what our end consumers are telling us. I'll give you a couple of facts. 95% of all of our end consumers are female. About 30% of our end consumers are now Generation X and the millennials. What those end consumers are telling us is that the expectations of mining are changing, and the days of destroying the environment and having large footprints is probably coming to an end. And if we don't change, it'll be changed for us. So my slide will talk about that. And the other challenge is for the mine designers in the room is we have to do things radically differently. And I'll show you a little bit about that in my few slides. I think I pushed the green button. Is that right, Adrienne? Yeah. So if you just bear with me a little bit, I'll talk a little bit about De Beers in Canada. Some of these topics up on the screen, where we are, what our footprint looks like, some of our existing mines, and some of our future projects. So I'll take you through that. Familiar map for most of you of Canada. You can see where we are located. We have a very large geographical footprint, as you can see, across Canada, ranging from the Northwest Territories, where we have two assets. One is on care and maintenance and one is in operation. We have an office in Yellowknife. We have what we call a support centre in Calgary. It used to be here in Toronto, and we moved it a couple of years ago to get closer to the centre of gravity. We have the Victor mine in northern Ontario, which is a very, very important asset along the James Bay coastline over there. We've got an exploration office here in Toronto, a treatment facility in Sudbury, and probably the most exciting of all, a new asset we've just purchased up on Baffin Island, which we acquired from Peregrine Diamonds, and it's called the Chidliak Project. So that's our footprint. These are some of the existing assets, and what we're just showing you here. Two things. That sort of classic mine footprint is probably familiar to most of you. As you're well aware, some of these environments are pristine environments. So I just draw your attention to, first of all, the size of the footprint. Even though they're quite small by, let's call it, conventional mine standards, we still have footprints that are easily 100 square kilometres in extent. And you can see some of the water around these operations. They're really pristine environments. You can see Victor, which was built back in 2006 and came into production in 2008. Fortunately, it draws off the energy grid in Ontario, of which 60% is nuclear, and about 25% is hydropower. So we do have the benefit at Victor of drawing off a large renewable supply, not of our doing, but very fortunate that we could connect into that. The Gotchako mine, on the other hand, up in the Northwest Territory, is 100% diesel-powered operation, as is the Snap Lake mine. I won't read all the detail at the bottom. The only other example in the Northwest Territories of someone that has achieved renewable energy provision is the Diavik mine, which is a Rio Tinto mine, Ron, and about 10% of the Diavik mine, 10% of the energy comes from renewable, which is wind in that case. You can see for Victor to access that Ontario grid, we had to build a power line 100 kilometres long to get into that energy provision. I'll come back to this project, but just to add to our portfolio, we acquired Peregrine Diamonds. That transaction was completed a few months ago. That asset gave us 3 properties in the NWT, or 3 diamond assets, and there are 4 in Nunavut. The most important of that is what we call the Chidliak cluster, which consists of about 74 kimberlite pipes on South Baffin Island. I suppose it's worth noting that that region, as most of you probably know, whether it's Iqaluit or Pangnatang or some of the remote communities, all run off 100% diesel. It's probably a poor indictment of what can be achieved in some of these places, and so I'll come back to that. That photograph probably gives you a bit of a feel for how extreme the operating conditions are for the new Chidliak asset. It's about 100 kilometres from Iqaluit and about the same distance from Pangnatang, a more remote place we couldn't have found. So thank you to all the geologists in the room. So just a little bit about where we are now. In terms of what we've been trying to do with our existing assets, and there's a bit of a message here. We have quite a few De Beers people in the room that have spent endless hours trying to optimize our existing conventional mines and see what we can do to improve our energy footprint. From a De Beers group level, we've got quite, as most companies do, I'm sure for many of you in the room, have quite strong energy reduction targets. You can see what ours are there, 8% reduction in energy and a 9% reduction in carbon. But truth be told, that's tinkering around the edges, because to achieve those kind of improvements, we'll just be doing little incremental changes year on year. And you can see Victor Mine has done that. George Shields, who comes from the Victor Mine, is sitting here today. He's been involved in about 70 different programs to try and reduce our greenhouse gas emissions, and you can see the numbers down below there, about $20 million in savings, 21,000 megawatts of electricity saved annually, and 5,500 tons of carbon reduction. But that's basically working with an existing conventional footprint. I mentioned Snap Lake. It's on a diesel. Fortunately, we're not running it at the moment, so we're not using much of that diesel. I don't know how many of you sort of know the numbers. I'll just give you some interesting numbers. In the Northwest Territories alone, the 3 diamond mines that are up there that are currently operating, so that would be Gotchako, Diavik and Ekati. Between the 3 of us, we move 170 million litres of diesel up in the NWT to power those 3 operations. If you add to that what Yellowknife consumes and some of the communities, 250 million litres of diesel is transported up and burnt annually to supply either power or energy. And in some ways that sums up the size of the problem, but also the size of the opportunity. Gotchako down the bottom there, it was designed and built on a 100% diesel basis. It's using probably the best state-of-the-art energy provision. I know Caterpillar in the room, and they provide some of our generators up there. And it's probably one of the better facilities. We were able to reduce the size of that footprint, so our energy provision at GK is quite small compared to some of the other operations. I think this is probably the power slide in my pack. It really talks about the case for change, and I think this is what I really wanted to talk about. If you start on the left-hand side there, I said that we are a consumer-facing business, and what we are hearing from our consumers is their appetite to buy products from mines that have these big footprints, that don't use renewables, that on the face of it appear to destroy the environment. That appetite is reducing very rapidly. Lightbox, many of you probably don't know what that means, but from a De Beers point of view, obviously we mine natural diamonds, and what's been growing over the last decade or so is the advent of synthetic or laboratory-grown stones. So for the first time in our 140-year history, what we're facing is a point where consumers can choose between a laboratory-grown diamond and a natural mine stone. And of course, what they then do is they juxtapose the two footprints and they compare how we produce natural stones with how synthetic stones are produced. So that's given us a really interesting point of focus in terms of how we actually mine. I think on the right-hand side, we've seen governments around the world imposing carbon taxes and trying to influence us all. That's clearly not going to go away. You can see some of the dollar impacts on the middle of that slide over there. The other interesting thing is if you look on the left-hand bottom there, from a diamond perspective, what we're finding, and it's no different to other minerals, it's getting harder and harder to find minerals in easy locations. You don't find mines 10 k's out of Toronto anymore. Those days are long gone. So things are either a long way away, the assets are changing. In diamonds' case, they're getting smaller, so you can see how the footprint's evolving. So all of these things are coming together to form a perfect storm for change, and certainly in our industry. And I think that's one of the key messages I wanted to send today, was that there's a very strong case for change, and to all the miners in the room, we have to do it. Just a couple of slides about whether renewable energy is feasible in the Arctic. We had a look around the planet, not just in the Arctic, to see who's doing this. That picture on the top right-hand side there is a mine in Western Australia. About 20% of its power comes from solar sources. I mentioned Diavik earlier on, at about 10% coming from wind. The Princess Elizabeth Arctic base is fully renewable. You can see it's got wind, and to our knowledge also got a little bit of solar and a few other things. Obviously there's a battery facility there somewhere, but that's a great example of something in the Arctic that actually is 100% renewable. There's a key feature though, which we've learned from by looking at that picture, which is it's small. And so footprint is very, very important when it comes to this topic. And that's why I reference the size of our mining footprints. 100 square kilometres or 200 square kilometre footprint, you're really going to struggle to change the dial when it comes to renewables. Down the bottom there, a deal that's just been signed with Antofagasta and Barrick on the Zaldivar project. They're also tapping into 100% renewable sources as part of their supplier agreement. So the dial is changing. Bottom left there, the new project that we've just acquired, our goal is, can we make that project 100% renewable? I mentioned, I asked for a show of hands of mine designers in the room. The more we've applied our mind to this problem, the more we've realised the only way you're going to achieve this is you have to change your thinking about how you mine. You cannot keep thinking conventionally. That top left-hand picture, what that compares is the size of a conventional processing facility, which I'm a mining engineer and most processing facilities are roughly the same. That happens to be a diamond one. So the left end, the big block, the one with the yellow and green, is the size of a conventional processing plant. In fact, it's the one we built up at Gotcha. The little building on the right-hand side is the size of our latest thinking. Is could we actually make it radically smaller? In fact, that's more or less to scale that picture. That bottom little little processing plant would take 2 of those to produce as much as the big one. So why I'm just showing you that picture is it is possible if you really challenge yourself to dramatically change the size of the footprint. On the right-hand side, obviously, very, very important if we're going to achieve this to partner with as many renewable providers as we can, with solar, wind, geothermal. We have even thought about the nuclear word as well. Energy storage, very, very important. We understand that battery solutions are critical to this because you've got to store that energy somewhere. So battery solutions is important. But I think the bottom right one is the most important one, is that can we actually change our mining solution so that we dramatically change how we mine these kimberlite pipes. As we build this new project up in Baffin Island, we'll be trying everything in our power to change the footprint, to change the way we mine, and to dramatically change the dial. We're calling Chidliak the poster child for off-grid Arctic renewable energy. We know that we carry a big burden of responsibility to do this. Ironically, when you actually look at the design for that mine, one of the biggest hidden costs of the mine is actually building a road from Iqaluit to the project. If we can remove that road, and the reason you'd build the road, by the way, would be predominantly to bring diesel into the operation. So if you can change your energy provision, you potentially don't need that road. That changes the capital cost and a few other things. We've talked about that site being a fly-only site. Can we actually build a mine where we're only accessing it by flying in, whether it's by chopper or aeroplane, but choppers preferred because then we don't need a runway. We do have a bit of an advantage. I said that the footprint of the ore body is quite small, so that helps us. But as I mentioned early on, the eco-credibility of that project is very, very important to us. And so when we bring that project online, we want to bring to market a supply of diamonds that people can buy with a very, very clear conscience, knowing where it's come from and what we stand for. We still believe that industry cooperation is necessary to achieve this. We're all under increasing pressure, but what we're seeing is our social license to operate is actually at risk. So maybe just to finish off, I'm sure we've all seen this, sites are becoming more and more remote, further away from infrastructure. We have to push the envelope. We're not just thinking autonomous trucks, we're thinking no trucks. We're thinking no concrete. We're thinking no roads. So we're trying to push the boundary in every single dimension. We know that we have to invest in technology and be bold, and we're doing that. It means we have to change, from a corporate point of view, our appetite for risk, something we're doing as well. And then just the last point there, society's expectations are moving faster than we realise. And so I think the sooner we get onto this, the better. So anyway, I'll end there. I probably went over my time. Adrian, I didn't see you going like that with your hands, so hopefully it wasn't too long, but thank you.